naturally. How do we go about that? Du dx will be 2. Because this is raised to power 1. 1 times 2, 2. Then 1 minus 1, 0. X raised to power 0, 1. 1 times 2, 2. Depending on the constant, 0. So this is what you have. Then dy du. If you have to differentiate dy du, this is our y, this is our u. So 5 comes to the back. 5 minus 1. That's how to differentiate that. And that will definitely give us 5 u raised to power 4. Are we looking for dy du? No. Are we looking for du dx? No. What are we looking for? We are looking for dy dx. So dy dx, which is now equals to dy du. What is our dy du? That is 5 u raised to power 4 times du dx. What's our du dx? That is 2. So automatically then we have dy dx equals to 2 times 5, 10 u raised to power 4. We have dy dx. We have 10 u raised to power 4. Remember that our u will represent it with an equation. In the original, remember, we made an assumption here which we must effect here. So our u is 2x plus 5. So I will just say dy dx will definitely be equals to 10. What's our u? 2x plus 5. Then raised to power 4. So this is what we have at the end. So let's compare. You can see that this is not different from this. But this is a short method. But this is the appropriate method of solving it. Let's consider another example to buttress more on functional function. We have y equals to 3x squared minus 5 divided by 6. We have 6 over 3x squared minus 5 raised to power 2. If you look at this now, this is also a functional function. But it takes someone with a sound understanding of mathematics to know that this is a functional function. I will make it look like a functional function. Now you have y equals to, this can be written as 6 into 3x squared minus 5 minus 2. So that is what we have. Then we call this, by law of indices, we know that this can become this. Then we can say let u be equal to 3x squared minus 5. Then y will now be 6u raised to power minus 2. We differentiate, our interest to look for dy dx. So we differentiate du and dy du. We multiply it by du dx, which is functional function. So let's do dy du. Yeah, minus 2 times 6, that becomes minus 12. And we subtract 1 from this, so that becomes minus 2 minus 1, and that will give us minus 12 u raised to power minus 3. Then we differentiate these two, du dx. 2 times 3, 6. Subtract 1 from it, that becomes 6x squared minus 1. Differentiate the constant, 0. So you have 6x. So our dy dx now becomes dy du times du dx. So dy dx will now be equal to, what's our dy du? Dy du, that's minus 12 u raised to power minus 3 times du dx as 6x. Minus 12 times 6, that will give us minus 72. If I'm not mistaken, yes, that will be minus 72. So you have minus 72 u raised to power minus 3. Remember there's an x here. Or you can try to write that dy dx equals to minus 72 x u raised to power minus 3. So we replace our u. What do you have as our u? This. So we have dy dx equals to minus 72 x into u. What's our u? Our u is 3x squared minus 5 raised to power minus 3. So dy dx will now become minus 72x over 3x squared minus 5 raised to power 3. And this is our dy dx. Product rule. Product rule. In product rule, we are considering product of functions. Product rule. So you have y if y is equal to uv such that u and v are function of x, are functions of x, then we can say dy dx is equal to u dv. That means dy dx, we close this and differentiate this. So if we close this, that is u. We differentiate this dv dx. Plus, we close this, that will be v. Then we differentiate this du dx. So this is the formula for product rule. Very, very important. So how do we determine that? Let's consider example. Differentiate. Or they can say find dy dx. It is not necessary they have to tell you differentiate. Sometimes it can be asked dy dx or f prime of x. So differentiate s cubed plus 1 minus x squared. You have to differentiate this. Y equals to this. Then if you have to differentiate this, this is a product rule now, because you have a particular function multiplying another function. So here we just say y equals to x squared, x cubed plus 1. Let this be your u. Then 1 minus x squared, let this be your v. Remember that your u, your v. So you have to look for du dx. Your du dx, differentiate this, that gives us 3x squared. 3x squared. This one becomes a constant 0, comma, dv dx. That will be minus 2x. That will be minus 2x, because these two comes here and subtract 2, minus 2x. Then we now go back to our formula. Then our dy dx will now be equals to, what do you have? U. What's our u? Our u is s squared plus 1 dv dx. Where's our dv dx? That's minus 2x plus v. What's our v? Our v is 1 minus x squared du dx. What's our du dx? 3x squared. So this one, dy dx, automatically will give us minus 2x into x cubed plus 1. And this one becomes plus 3x squared into 1 minus x squared. So let's open this up. We have minus 2x raised to power 4 minus 2x squared, minus 2x rather. And this one plus 3x squared minus 3x raised to power 4. This one and this one, they are similar, so I can say dy dx will definitely be equals to minus 2x raised to power 4 minus 3x raised to power 4. That gives us minus 5x raised to power 4. And this one will be plus 3x squared minus 2x as the answer. Quotient rule. The quotient rule is also related to product rule, but difference is that you have a division this time around. In the product rule, you have multiplication. So let's say if y equals to u over v, such that u and v are functions of x, then we have dy dx will be equals to v du dx minus u dv dx over v squared. That's the formula for calculating of for determining the quotient rule. You close this, differentiate this. You close this, you differentiate this over square of this. So let's see example. Example 1. Find the derivative. Find the derivative of 1 plus x squared over x squared minus 1. So you are given a function like this. You have to apply the quotient rule because you have a function dividing by another function. Then here you assume that let u to be equal to 1 plus x squared. Then your v is equal to x squared minus 1. So let's differentiate u. du dx will give us, differentiate the constant 1, 0, differentiate this 2x. dv dx will give us 2x2. So now our dy dx, which is now what? V, what's our v? Our v is this, x squared minus 1 du dx 2x minus u